All right, today we're going to be looking at 7.1. This is properties of the normal distribution. So the normal distribution is one of those we saw in the first chapter. It is a probability density function, PDF. I know in the previous video I said use the D to refer to discrete and continuous when we were finding the probability of those, but the actual meaning of PDF is probability density function. And then here are a couple of the properties that you need to be familiar with when identifying a probability density function. So one, the area under the graph is equal, the total area under the graph of the equation over all possible values of the random variable must be equal to 1. And then the height of the graph of the equation must be greater than or equal to 0 for all possible values of a random variable. So basically what this means is the total of all the probabilities have to equal 1, just like any probability distribution. And then the height, which represents the probability, has to be greater than or equal to 0, which means non-negative, I don't think we can have anything greater than 1. It says must be greater than or equal to 0 for all possible values. So those are a couple of properties. You got some examples that they show you. One of the other things we're going to be looking at is the uniform distribution. Its area is just basically the formula for area of like a rectangle or quadrilateral. It's length times width or base times height. So you find the measurement of the base, the measurement of the height, you multiply those, and that's what you're seeing up here. Then we have some distributions. This shows approximately normal curves. It's not exactly, but it's close. Most of the areas underneath, little teeny bits come out above. So a continuous random variable is normally distributed or has a normal probability distribution if its relative frequency histogram has the shape of a normal curve. So this is kind of general normal. What you should be familiar with is the mean is in the middle. Okay, the mean is the high point. And then you have inflection points, which this graph is concave up like a U shape. And then when it hits this point, it begins to turn to go concave down. So this inflection point just looks at change of direction from going up to concave down, like a U shape to going to the N shape. That inflection point is at the mean minus or plus the standard deviation. And it's explaining that a little bit here. So properties of the normal density curve, want to be familiar with these as well. So the normal curve is symmetric around the mean, which means half is to the left and half is to the right of the mean. Mean equal median equal mode. For a normal curve, it has a single high point. The highest point occurs at the mean. Normal curve has inflection points at the mean minus sigma and plus sigma. Area under the curve is 1. Total area under the curve to the right equals area under the curve to the left, which is 1/2. So again, that's the symmetric property. Half is to the left, half is to the right. And then 6. As x increases without bound, gets larger and larger, the graph approaches but never reaches the horizontal axis. As x decreases without bound, gets more negative, so it's going to the left. The graph approaches but never reaches the horizontal axis. So that's just saying as we get close to the end, we're getting closer and closer, but never really touching this x-axis on both sides. You got the empirical rule, which we're being reminded of. 68% is under the curve between one standard deviation. 95% is between 2 standard deviations. So if you go 2 out from the mean, that's about 95%. And if you go 3 out from the mean, you get about 99.7, almost all of it. You have this figure kind of showing you that visual. you got some examples that they kind of explain here. Now this is the formula for the normal distribution, but for the most part we're going to be using that z-score and the probability table, but this is the actual normal formula. We will not have to use this, we'll just focus on the z-score and using the table. So area under the normal curve, got you some characteristics here, and I'll show you how to read that table when we get there. And let's jump on over to my math lab.